So good afternoon. We can start. So thanks for joining this session. The session will be led by Francesca Mani and myself.
Yeah, good afternoon, everyone, and welcome to the main session of the Industrial and Trustworthy AI track of EBDVF. I am Francesca Manni from Philips Research, and together with Milan Petrovic, I will moderate this session today. So first of all, I would like to thank the speaker and the audience for joining the session, and I would like to introduce the session and then leave the floor to Milan to proceed with the speaker introduction. So the main goal of this session is to address cross-sectionally the challenges related to applied AI system and their trust. We would like to tackle the subject from different perspectives, and in particular to bring together different views from academia and industry for future interoperability. So in one hand, the AI is becoming the central drive of innovation in every aspect of industry, and in the other hand, there are legal and tech and ethical challenges related to trustworthiness that needs to be addressed. We will reflect also upon the AI Act and its effectiveness in providing a framework for developing AI applications which are compliant to legal and ethical guidelines. So we would like to answer the main questions like how do we ensure the development of a trustworthy AI system? Do we trust AI application? So before discussing and answering the following question, we will start with a brief introduction from the speakers, giving their views and roadmap on trustworthy AI, and then we will continue with the panel discussion. So Milan, you can proceed introducing the speaker.
Thank you. Thank you, Francesca. So I'm very happy that today we have a very interesting speakers. We have Blaž Fortuna, who is the managing director at QLector, which is a startup company developing AI solutions for manufacturing, logistics, and finance industry. Blaž is also a senior researcher at Joseph Stefan Institute in Slovenia, and he is also initiator and a contributor to QMiner, which is the open source data analytics platform for processing large-scale real-time streams. Blaž did his PhD at the Joseph Stefan Institute and was a research consultant from Bloomberg, and also he was a Marie Curie Fellow at Stanford University. I'm very happy, Blaž, that you're joining us today. Next to Blaž, we have Marcelo Jenka, who is a principal investigator and group leader at EPFL in Switzerland. Before EPFL, Marcelo worked at ETH in Zurich at actually Department of Health Science and Technology. He was also an ordinary member of the Competence of Rehabilitation, Engineering and Science at ETH. Marcelo's research focuses on ethics and governance of biomedical data, ethically aligned artificial intelligence, responsible innovation for emerging technologies, and human-machine interface. He was a principal investigator of interesting projects such as neurotechnology, artificial intelligence, and human rights, or digitizing elderly care, etc. So he has a PhD in biomedical ethics, summa cum laude PhD from University of Basel. So, and what I find also interesting is that Marcelo is co-founder and editor-in-chief of Scienza Live, which is an Italian-speaking web portal that is sort of busy with public understanding of science and technology. So Marcelo, very pleased that you're also joining us today. Finally, we have Arnold Smulders, a professor at University of Amsterdam, who is actually, I know for a very long time, a very known person in the area of computer vision. He was a scientific director of Commit, which was public-private partnership in the Netherlands in the domain of ICT, with 70 partners, budget of more than 100 million euros. So he also is very much involved with the spin-offs and startups. Currently, I think co-founder of Kepler Vision BV. Finally, Arnold, I know from ADRA, where actually he's on the board of directors, one of the directors of the board. And ADRA is, as you know, the association which was established by BDVA, Eurobotics, Alex Clare, and Eurorobotic and EuroAI to be the private side of the new public-private partnership on AI data and robotics. So, Arnold, I'm very pleased that you're also, thank you for joining us. This session, as Francesca said, we'll organize in a way that we'll have the opening statements from our panel members, and then we will move to the question-answer session. So feel free already to put your questions in the chat, and we will also bring them to the panel members. So, Blaž, we would like to give you the floor for your opening statement. So I understood that you want to share also some slides. Please use screen sharing, and the floor is yours.
Thank you. So, thank you, Milan, for the kind introduction. So let me just share my slides. Okay, so I have just for this opening statement, I'd like to share some more like from the use case, some experience, or how do we see how we build trust between the AI application and the stakeholders that are part of the AI application. And to develop this use case, I'll focus on one particular complex system, which is a factory. So if you look at the factory, so everybody kind of has some rough understanding, but actually there's many different layers or systems or silos that are functioning in a factory, which makes it quite complex system and a good ground for developing AI applications. So if we just illustrate what I mean by complex system in a manufacturing plant. So we have many layers ranging from strategy, which are mostly done structured in unstructured documents, going down through sales, through schedules, logistics, human resources, lots of informal knowledge of how to manage all the things down to production lines and machines. And we can address each level individually with different AI applications, from forecasting down to anomaly detection. Or we can manage this uniformly, so developing a digital twin and a model that helps us then make decisions and kind of act. So we have kind of feedback loop. So this is just as a context, and maybe the same thing, but from a different view. Here we have pillars of so Industry 4.0 digital maturity pillars. So there again, we start with very basic things, visibility. So what is happening on the shop floor, for example, this is already covered by existing systems, but as we go on, so why is something happening? Transparency, predictive capacity. So what will happen next, and also adaptability, so being autonomous. This is where AI comes in, and this is where I want to focus on building trust. So if you have a system that predicts how the factory will look like tomorrow, how to manage all the interactions and develop a relationship with the end users around it. So if we focus on how do we typically see these things? So the key is to establishing trust with the end users of the systems. So one of the stakeholders, and there's a big difference between end users and AI practitioners. So we have on one side, we want the end users to develop understanding where AI can excel, so where AI, different areas of AI can help them. And on the other side, we need end users to understand which part of the existing processes, so things that are either production or business processes, are easy and which are hard. So this is a non-trivial task usually, and the harder the problem is from an AI perspective, the harder it is to develop trust around it as well. And also it's good to start with the low-hanging fruits to get some quick wins. Also all the stakeholders in the system can see where the benefits are coming from, and also motivates them to give more trust or give them more responsibility to the AI system. So there's one big issue comes from data quality. So each system, the existing IT systems, there are always blind spots. Once you start implementing some prediction, we can see we figure out that there's some data that so far nobody used, or so far it was kind of just somebody done with an email, and kind of covering these blind spots is important, because otherwise we can get very unrealistic results. And also the data integration. So this is also a place where we want to leverage AI methods, so we don't to speed along. And we have to work all the time on building a positive perception. So one way of looking at it is we are building system, we are developing agents that are helping the end users. We are not taking the responsibility, we are not taking tasks from them, but we are making systems that help them be more productive at the end of the day. So one approach is this. If we start for easy start, is to start with decision support. So not going finishing the full loop automatically, but start with providing insights, what we think will happen, and which are the interesting parts the user should pay attention to. And this helps helps at understanding. Visualizing how the AI system sees the future. So then the human can the end users can compare this to what they see, and slowly see if it aligns or not. If it's not aligned, what can we do to get them aligned? If it's aligned, then this trust relationship starts establishing. We can start being more proactive, so notifying about business impacting events, and you can also start slowly suggesting what to do to get around things. So kind of having this step-by-step approach to kind of letting the end user slowly release small parts, chunks of responsibility to the AI system. And of course, the end goal is to increase the productivity through automatization, but we have to get there, so we can't just jump in head first. Another part that is quite important is explainability. So it's good that we are able to explain the predictions. It doesn't need to be 100% accurate explanations, but just to see from which part of the history, from which part of, I don't know, training set helped us decide on what we predicted here. Did we see similar events in the past that we can anecdotally help to explain this prediction? Ability to explore the historical data, considering the given prediction. So these kind of things are quite important. One thing that is not often mentioned is traceability of changes. So as the underlying models, the AI system change, keeping track of the differences, what is changing, which part of the data set, the training data or user input, what are the triggers for the updates. So having to see if the end users get used to some kind of reaction of the system, and then next week it's a bit different, you should be able to explain where this difference comes from. And one thing is also that we noticed, in the organization you need one or more power users. These are people that can basically come from the domain but are skilled enough in the system that they can kind of debug some of the prediction. So if one employee comes and says, okay, this prediction does make sense, so this power user can go in using all the things that mentioned above and figure out together with the end user why this prediction happened as it is, and is it correct? If not, what can we do to improve it? Maybe just to summarize a couple of challenges. So one is that we need to develop this trust during the implementation, and this phasing of the rollout is quite important. At the end, we must have an impact on business processes. This requires organizational change. We must educate the users on the capabilities so they know what is easy and what is hard. So it's kind of their expectations are aligned. And lastly, it requires discipline. So to keep the blind spots to the minimum, so things don't happen outside the system, because then the system is blind in a sense. That would be all from my side.
Okay, thank you, Blaž.
Thank you, Blaž, for your nice presentation. I'm sure this will be an hint for our panel discussion, so we can continue later discussing about this with addressing question to you. Would like to give the floor to Marcello. Marcello Janca, the floor is yours. Thank you.
Thank you very much, Francesca, and also thank you very much for having me here. It's a great pleasure and honor to participate in this event. My primary area of research and expertise is AI ethics. So in my input presentation, I would like to provide some general information about the global landscape of AI ethics guidelines, because this is a rapidly evolving area of AI governance where many of the issues relating to trust that we will discuss today are being addressed by both public and private sector actors. And I'm just going to share some information from a published report that I co-wrote with Afi Vallena on behalf of the CAHAI, the Ad Hoc Committee on Artificial Intelligence of the Council of Europe, which in turn is an expanded version of a paper that we published in Nature Machine Intelligence. And in these two documents, we try to provide a review and analysis of the current corpus of AI ethics guidelines. We counted 116, and since then, new ones have been published. And we have seen that most of these guidelines are being developed by governmental agencies, followed by private sector actors, especially those involved in AI development, but also consulting firms and so on. Third, academia, so academic societies, research organizations, and so on. And finally, NGOs. And we have also seen a variation over time in the publication of these documents until 2018. Now it seems that the pace of production is slowing down. We've also observed a very radical disparity in the geographic distribution of these AI ethics guidelines. So this graph shows the frequency of AI ethics guidelines being developed in various parts of the world. And as you see, although AI is a global game, AI ethics and AI governance seem to be a first world game, with the majority of guidelines being developed in Europe, North America, and Japan. And with the global South, especially South America and Africa, being very little involved in this governance effort. I'll summarize some key findings from this analysis we conducted. So one interesting finding in my view is that an increasing number of governmental and non-governmental organizations are developing ethics guidelines or other forms of soft law instruments. And soft law means that is not legally binding. It's persuasive in nature as compared to hard law, which is legally binding. These documents are being primarily developed, as I mentioned, in Europe, North America, and Asia. So there are many regions in the world that are currently underrepresented. And in terms of content, we have seen that these AI ethics guidelines tend to agree on some generic principles, and I'll show you which ones. But they also sharply disagree over the interpretation of these principles and also on the details of what should be done in practice. And we have also seen that no single ethical principle is common to all 116 documents, meaning there is no full consensus. So we found growing agreement around the following ethical principles: transparency, justice, non-maleficence, which means do not harm, so safety principles, responsibility, and privacy. But at the same time, we observe that ethical considerations regarding sustainability, dignity, and solidarity appear significantly underrepresented. And in terms of transparency, which is the #1 principle, we have seen that most guidelines agree that AI should be transparent to avoid potential problems and to build trust, which is relevant to our session. But it does not appear to be clear whether transparency should be achieved through, for example, publishing source code of algorithms, or by making the underlying databases more transparent, or by some other procedural means. We've also seen that slightly more than half of reviewed documents explicitly recommend the promotion of human rights in AI, which is good, but it also means that the remaining half does not make any reference to the promotion of human rights when designing, developing, and deploying AI systems. And then we also run some regular expressions from the codes to reveal significant variations in theme coverage between documents produced within member countries of the Council of Europe and the rest of the world. And it turns out that the documents produced within countries that are members of the Council of Europe emphasize the ethical principles of solidarity, trust, and trustworthiness more than documents produced in the rest of the globe, which seems to suggest that trust and trustworthiness are not necessarily globally unanimous ethical value, but something that we care more about in the European space, largely broadly conceived. So here you have a visual rendering of the frequency of these ethical principles. Trust and trustworthiness, as you see, are here. So they're represented in less than half of the documents. But among those that do refer to trust, interestingly enough, the previous that are more common, such as transparency, fairness, safety, accountability, and privacy, are recognized as key determinants and predictors of trust. So mentioned earlier, so transparency is very common, but it's unclear how transparency should be achieved, for example, through audits and auditability. But some other actors propose different suggestions. Among the principles that are represented, that are cited less often, I think trust is a very good example of an ethical principle that is poorly understood, or at least that is interpreted in many different ways. So we observe that most references to trust include calls for trustworthy AI, such as in the EU framework, or in trustworthy AI developers and organizations that should apply trustworthy design principles, or they underline the importance of customers' trust. However, we observe two main conceptual problems. The first one is that these guidelines lack conceptual clarity on the meaning and dynamics of trust. As an ethicist, I like to emphasize that trust is a relational and highly complex concept, which involves at least two actors. One actor trusts the other actor to do or not to do a certain activity. And this relationship is usually among peers. It can hardly be established between humans and AI systems. And it's also influenced by diverse framing factors, such as culture, belief systems, context, and others. So trust is highly situational, and it's very difficult to develop trust as a general concept for AI, in my view. And the second point is that we observe that the trait of trustworthiness and the relational construct of trust are often conflated or used interchangeably in AI ethics guidelines. And this conflation does not only lead to conceptual confusion, at least in my view, but may also foster false hopes among AI users and developers. And to conclude with some final policy implications, we also observe that this soft law instruments are very useful tools. So they are really shaping the way AI is developed and governed internationally, but they exert practical influence on decision making. But at the same time, they should not be considered substitutive of mandatory governance or hard law, because due to the high risk of conflict of interest, the self-regulation efforts by private AI actors are more likely to be exposed to the risk of bypassing governmental or intergovernmental authorities. And then we observe, since geographic distribution was subject to disparity, that there is a need to ensure more inclusiveness and cultural pluralism and fair participation to collective decision-making on AI. And I think this could be a key prerequisite to build trust in the AI industry at the global level. And finally, that the convergence of soft law instruments around certain ethical principles such as transparency, justice, non-maleficence, responsibility, and privacy identify possible areas of oversight that should be developed by further governance. And one final note, it's on the importance to clarify this concept. So I mentioned earlier the semantic ambiguities that need to be resolved, and trust in particular is a key example of this. If we avoid this kind of conceptual clarification or clarification on the interpretation of trust, then we may develop solutions that are likely subject to public disagreement. Hence, will require a higher degree of transparency in the democratic deliberation process. And finally, the underrepresented ethical considerations need to be further scrutinized to avoid importing into future governance the same gaps and normative blind spots of current AI ethics and soft law. Thank you very much.
Thank you, Marcello. So now we heard actually the view from Blaž with the perspective of a startup company. We heard Marcello who gave us perspective from the someone who works on ethics. Now I would like to invite you, Arnold, to give us your perspective. I assume very much perspective from the research point of view.
Let me see here. Is that all right? Do you see the screen properly?
Yes, yes.
I think this is scientifically, this is a very interesting topic, because other than most science topic is not under your complete control, what we are discussing today. So that's why it's very interesting. I've brought the work of two of my students with me, and I'm representing here also the ALICE, that is the Network of Excellence in Research in AI, read machine learning. Okay, so the first question I would like to put on the table is, do you have a dentist, and are you satisfied with the dentist? And let's assume the answer is yes. Good for you, congratulations. But now the question is, how do you know? And there is, I once thought in my life I had a very good dentist, because he didn't say very much, and he was just doing his work. And it was an old man with gray hair. And then I went to the next dentist who was young, and they said, and to my surprise, he said, well, that is rubbish. We all have to replace it. So, okay. So this is a tale of fear and trust. I could have also taken the example of how do you know your vaccine is good, but that's maybe a little bit too hot to discuss today. So keep in mind, why do you trust your dentist? Because that's, well, maybe because he's predictable. If it's a he, actually, it could also be a she, of course. He's respectable in his general behavior. He is limited in the sense of he doesn't sell you flowers while being a dentist. He's prepared to communicate. So this is, in general, the way trust is built. And now trust is a very interesting property, as already discussed before, because it's not an engineering problem. You cannot set a goal and then you do 5 steps and then you have it. It's essentially a voluntary consent from the other side. So you can behave in a certain way and then hope that on the other side trust will build, but that's about it. Okay, let's translate this to AI. Most important aspect of trust is that it is producing predicted results. In other words, the robustness. And not only the robustness in general, or the performance in general, but also when the circumstances are a bit off. You all remember these photographs where people were classified as a monkey and reverse, and that immediately took away all the confidence in this dentist, right? And the same holds for, do you have a reasonable explanation? We get back to that. We get, do you only consider this, or do you drag in something else? Is the limits of the request, the limits of the control, and the fairness. I will focus for my own research on the first two, but also discuss the later three. Okay, so the robustness is done when the model is not ideal. In other words, there is something, there is some form of disturbance. There is a famous one. It's called adversarial. It was a sensation in research. And by the way, for our purposes, it's practically useless. We've recently demonstrated if you do adversarial training, that is, you add a little bit of noise to such a degree that our image hardly changes, then you can have all sorts of wrong results. Well, good for you, but this is almost a deliberate takeout, which will rarely occur because the training images, very few people have access to do this deliberately. It could be, but that's extremely rare. And if you use adversarial training, like you feed these images with maximally optimized noise to get it off the rails, then it has no predictability on or no influence on the other real life disturbances as you show, as are shown in the bottom: Gaussian noise, shot noise, snow, motion blur, JPEG algorithm, brightness changes, or deformations. None of this will sail comfortably through the adversarial training procedure. So it has, it's interesting to watch that only a little bit of carefully designed noise takes the machine algorithm off the rails, but for general purpose goals, where I have patterns in the deviation, that doesn't help at all. And this is taken from a reference where they've collected all sorts of natural noises. Okay, so what did we do? We took these types of known perturbations or common perturbations, like elastic transforms or local shot noise, which obscures the details of the image. And in the first run, we transformed the data and offer that also to the system. And then we concluded, well, you can make a system robust at the loss of very little of its performance. And but it's still, after that, much more robust, even to causes you have not trained it for. So that helps. And the second very recent step, it's now under review. So I can't tell you all about it, but I give you in the bottom part of the image, I give you one glimpse of what the method looks like. You take the weights in the algorithm, you deform them a bit, and then if you train with the standard images you have, it will be much more robust in general and even sometimes improve the original classification. So that's really what you want to do. So now you have, by taking a little bit care, you've made the machine learning algorithm more robust. I hope that the latter method is already available on arXiv, so you can read it. But I hope that it will be published, say, a few months from now. Okay, and the second step, as we considered earlier, don't focus too much on performance. Typically, 95% of all machine learning people are focusing on optimizing the performance. You can't blame them because that's their engineering task. But in practice, it's much more important to not super optimize the performance, but to explain what you do. Now, there is a stream of thoughts where you say, well, the only reasonable explanation is by giving rules. I've done it like this. Basically, what a general practitioner do to you. You have a flu because, and then comes maximally 5 reasons, and you go home satisfied because you've understood it. But a radiology person does not do it. He doesn't explain it to you. You have to believe her, or if you don't, she will point at you in the photograph, this is wrong, and this is wrong, and this is wrong. In other words, she does visualization. So depending on the situation, there are several styles of explanation, not necessarily only by text. And typically, the training of, for instance, an internal medicine is done by showing the most similar example from the archive, right? So that's another typical way of explanation. Okay, we've done also research there. So rather than going for a full force machine learning, we first did attribute classification to see what type of bird this was. So for instance, this is a cardinal bird. And why is it a cardinal? Because it's red, but it's not the only one who has red. He has also a red, how do you call this? I don't know the English word, but it was in fashion for a while in the Netherlands that you would have your hair like this. And now if you disturb it, it could classify it in the wrong class, but we can now explain it because if this is not there, it's not seen, we can explain that that's the reason why it is in another class. And the people in the multimedia retrieval community liked this paper very much. It's 2 years old. Okay. Privacy. Privacy is a very critical notion, and I think it's getting more and more in the field of attention. And the people in Europe think that it's their topic, but I can assure you in the US, it is also very well studied these days. And here, you remember the issue a few years ago. It was found out that cars would send their data to the manufacturer. And the assurance from the car manufacturer, he came from Germany, but that's not a big guess, of course, because all cars come from Germany. I won't tell you which one, doesn't matter. The answer of the engineering department was, no, don't worry, please, don't worry, public, because it's all anonymous, okay? So I've showed you here on the map, the data sent to the manufacturer for my car. Now I have, it's totally anonymous. Now I have a few questions for you. Where do I live? Where do I work? Who is my secret girlfriend? How often do I go and visit my mother? Well, the last two is not entirely clear because they can be changed, whether depending on which one I like most, but nevertheless, it is clear, right? There is nothing about anonymity at all. It's not sufficient. And differential privacy chops these black lines of one single route into parts, combines it with other parts from other cars, and then statistically you can't trace it back or reconstruct it to who it was, and you still can find general conclusions, like many people go from this part to this part by correlation. That's differential privacy for you. It's a non-trivial part of current machine learning, so to say. That's one solution. There are other solutions, but this is one. Okay. Now, controllability. We go back to the dentist. I trust my dentist because he behaves at what I give to him, my dossier and my teeth, he treats carefully. And this will be the most, I believe, the most persistent in the public awareness of AI. That It's building and building slowly but steadily. My biggest worry about AI is the accumulation, the unnecessary accumulation of all sorts of data given in the hand of nerds, right? If you assume that I'm a nerd too, then you trust me in my statement. Why would nerds own access to the private data of half of the world population? There is no need for it. And this is fundamentally an issue to solve within 10 years from now. So algorithms would fundamentally be redesigned to travel to the data rather than that the data travel to the algorithm. And it would, and when it arrives at the data, it should have trusted entrance. For instance, there is a famous researcher in the Netherlands, Bart Jacobs, who designed the IRMA principle, which is I relieve my attribute. And rather than answering cookie questions, which basically is the access to everything, especially and made in such a way that it is very hard to always do, the IRMA principle takes the other stance. It says I put a gate around my data and I let you in for the purpose I want. Also non-trivial, but I wanted to bring it up for the discussion later on. And then finally, fairness. In your lifetime, you remember maybe this. 5 years ago, 4 years ago, when you typed in the question 3 white guys, you would get one of these photographs back. And when you typed in 3 black guys, you get the other photograph back. And yes, you could say, well, I'm a technology company, so you raise the query, I've answered them. But it was a big issue that to the left, there are 3 guys from prison, and to the right, there are 3 guys from the beach. And the answer, well, the problem is in the data we learn from, so it is a societal problem, not our problem. That's the initial answer by Google. That's completely true, but it's no excuse. So you have to make it fair before you launch a public service. And that's completely non-trivial, and by now it's no longer valid. But I give you another example, which is valid until a week ago, at least. I searched for a male patient of a dentist on the internet. I hardly couldn't find it. There was exactly one instance. All other 199 images were of female patients. So Google may have solved this problem, but not the general problem. Let me put it that way. That's what I wanted to say for introduction. Thank you.
Thanks, Arnold. It was a very nice presentation. Yeah, as Milan said at the beginning and also before this presentation, we have now 3 different views from industry, research, and ethics. And yeah, maybe we can deepen a bit the interoperability and the difference in views and perspectives with our panel discussion. So I would like to introduce and start with this panel. And the first question that I would like to pick to introduce this panel is a question that I would like to address to Blas. And just to summarize what you have already presented and to give your view and start with a discussion that can, of course, continue by picking some questions from the audience. I also invite the audience to ask some questions. I would ask, so Blas, do we trust AI applications?
Maybe one view is that most of the time that we actually interact with AI with any form, we don't really realize that, or most people don't realize. So it's already going on, I don't know, on Facebook, deciding what you see or the ads you get. All these kind of things are kind of there, but I think not many people actually go and think how did this think, what is the all the kind of amazing technology at the back that makes this a little ad appear here and show it what it shows. And also that's one. So I think most of the time I don't really know. So it's hard to talk about trust in that relationship. It's just there. On the examples where people are explicitly aware they are working with, interacting with some kind of more maybe fuzzy system. So it's more, so there's some machine learning at the back, there's some prediction at the back. I think it's the default. You have two camps. One is that's what the machine says. Okay, that must be like that. I mean, I don't, and it's kind of also offloading the responsibility. And the other one is also very kind of suspicious. So having more thoughtful look. So thinking whether this number, maybe it says this, but maybe I should just hide up a little bit to default, because it's at the end, it's on me who is has to submit this report forward to the purchasing. So it's, I think it depends very much on the person, and it's also, it's most of the time we are not really aware of that we are actually interacting with an AI application.
Yeah, perhaps it's maybe good also. I think Arnold, you had an interesting examples with respect to this. Do we really trust AI and with dentists, etc.? So, and I think, I mean, all of us, we are professionals, and all of us, we try to do our job perfectly. Yeah. So someone is more perfectionist than the other, but everyone tries to do as less mistakes as possible. And we know that AI, on the other hand, comes with these performance measures, and that it's not all the time accurate. So does it make a real difference then how we actually should try to enable trust to AI? I mean, you were talking a bit about, yeah, Arnold, yeah, I was pointing to you because you were talking a bit about like whether we should focus on ensuring performance and ensure that basically this AI is really performant and all the time accurate, or we should try to put more focus on explaining why sometimes it's not accurate.
I would say the following. For some of the systems Blas described, you can take a rope and circle around the problem and completely close it. And if that is the case, when it's a completely closed problem, you can optimize it as we engineers do. Nothing to worry about. And when systems are a tiny bit open, and a dentist is almost a closed, but not exactly, right? So now we are focusing on what is the not open component. And then trust is, we cannot engineer anymore because we only can hope for it. And then comes in the things like, well, it may be technically perfectly perfect that you come up with a criterion Blas and the classification error or Kullback-Leitner divergence has been minimalized. Well, if I hear this and I'm a member of the public, I have no clue what you, so I have my own interpretation of it. And so I think that the first thing you do when you move to not entirely closed systems, and the dentist is already somewhat open, is to verify whether the perception on the other side is identical to yours. That if you say, well, I did my honest best, but I closed, I optimized the minimum classification error, then does the other side then perceive that as the identical point? And that's basically when robustness comes in, because the general public assumes that if you solve this problem, then the very close next problem you've also solved. And I've never seen a situation where if you can make the table for 5 people, why can't you make it for 6? Yeah, because it was not in the engineering problem. Yeah, sorry. Yeah. So, and that's the weak point of AI, that the generalization to even the slightest or standard deviations, and that's why we study robustness. But what we study is only the first step of robustness, common deteriorations. but common generalizations I know very little work of. So there is some, for closed systems, we all agree, right? And that's not the problem, and they should be, and the fear of the public and parliament on AI should there evaporate as soon as possible. But for open or half open or narrowly open systems, this is, for what I believe, the way to go.
And Arnold, does that mean actually then, let me just be provocative, that before we don't solve the problem of general AI, that we will not get trust into the applications that are not closed but open?
Well, there's also a practical point of view, and that if I'm in favor of driving a car on the highway automatically, because it's provenly better than if you do it by person. I'm against driving a car in the city because you can't trust it. But on the highway, this task, and so I don't believe that it's necessary to solve the general AI problem first, but I believe it is reasonable to think of the set of, does it generalize a bit? Does it, is it robust a bit? Is it, and to demonstrate these points into the conversation with the public, and think, trust from the public way of thinking, not from the engineering way of thinking.
Thank you. I think that's interesting. I don't know, Marcello, whether you want to add anything to this discussion from the ethical perspective.
Well, maybe going back to the question about whether we are trusting AI systems, I can translate this question into an ethical question, which is, should we trust AI systems? Because I think this is a very popular question in AI ethics and policy. Notably, as many people in the audience know, the European Commission's high-level expert group on AI has adopted the position that we should establish a relationship of trust with AI. But as I tried to mention in my email, in my input presentation, I'm quite skeptical that this is actually possible, because trust is a relationship between peers, and most importantly, it's a relationship between agents. You need to have agency in order to trust somebody and be trusted by somebody. And AI today does not have agency. Which does not mean it will never have agency. It will most likely will at some point, but then we should ask ourselves the question about whether it is desirable to have AI systems that have agency, and therefore to systems to which we can attribute more responsibilities. And I have a personal skepticism from an ethical perspective, that considering AI as peers with humans, and therefore is capable of establishing a trust relationship with us, is actually desirable. I think it can actually create ethical and legal ambiguities. In particular, I think it is essential that AI systems are never presented as morally responsible or legally liable in and of themselves, because moral responsibility and legal liability are based on human characteristics, such as being accountable in front of the law, and having the ability to suffer, being entitled to certain freedoms and fundamental rights, and so on. So when we translate this into AI systems, we may have some interesting ambiguities. Many people have argued, for example, Joanna Bryson, that considering AI systems as legal persons will be the ultimate shell company, right? Because then it will be very easy for human actors, including tech companies and so on, to outsource their responsibilities and liabilities to the imprescrutability of algorithms. And then if people are not responsible and they outsource responsibility to algorithms, then nobody is responsible, most likely. And this is a concern I share.
Yeah, indeed. No, thank you. Maybe going to a bit of like discussion with respect to the development of trustworthy AI systems. Arnold, you mentioned privacy as a sort of concern, and then by answering the last question, you were saying like, okay, there are these people that are developing the algorithms and these people that are using the algorithms, and obviously. We discussed that it's really important to understand the performance of these algorithms after the deployment. So we need to understand whether they are doing well or not, and to ensure that we can, build trust and ensure there is trust. So on one hand, we need more data because we need to understand actually also how they are used and what's going on. On the other hand, there is this privacy concern, and then you were talking a bit about also. Sending the algorithms to data. So perhaps maybe you can address this bigger question about the ensuring the trustworthiness during the development, but then also maybe address the point like how we deal with this. And then if you want, for example, to send the algorithms to data, how we ensure quality, because I mean, then the guys that are developing algorithms, they don't see the data. They don't know whether the data is good, but data is actually the fuel for the algorithm. So if the data is not good and not of a good quality, then the algorithms will be of bad quality, and then we'll end up with systems that are actually not trustworthy because they are not having good performance. So how you see this?
There's no fundamental solution other than what already exists in practice. So let's imagine a medical imaging company somewhere in the southern part of the Netherlands, and they want to design a good algorithm, a good predictive algorithm. What do? They collect data, and usually they go to certain academic hospitals to acquire them. Now, this is a current practice, and you could easily find an AI machine learning equivalent for that. Effectively, it already exists. But AI opens also more doors. For instance, if the disease is very rare, then you couldn't do it this way because it would take too long to acquire the data. So either you go to patient-related associations, or you try to collect rare data. And in the end, and rare data, but then of course you have to build trust, so it has to be sure that the data you use will not be wind up in public, but will wind up and be trusted to share. Almost every patient of a rare disease will be happy to do so, but it has to be absolutely certain that it's only for one purpose and for one purpose only, namely to find out more about the disease. So and in the end, you could say, well, if medicine progresses far enough, then every disease is rare, because we want to personalize the treatment to the individual qualities of one person. So the future is for the algorithm to travel to the data, and the data to be sufficiently protected. The current practice, I don't have to tell you, is in the social media domain, is completely different, and that ruins also the political viability of the previous scenario I painted. Because the political debate in the European Parliament is dominated by the practice of the social media. In times of COVID, I went to a terrace. I couldn't pay with coins. I had to pay with electronic means. So as I always do, I checked for one moment the app I had to download in order to be able to pay. We're talking about one espresso, so this was €2.20, and there were 75 companies who were sending cookies to my telephone, which were keeping the data between 2 months and 7 years. They didn't say in their what they were acquiring. I don't think it was only 220 they were acquiring, but that's a pretty useless number and not even a prime number. Yeah, so it is this is really 10 years from now, we will look back at this period as how has it ever been possible? That's not reasonable for a free app to pay in a restaurant for 75 companies to acquire data from my telephone for between up to 7 years, right? And but this is the current operational scheme, Milan. I think that, and it will not be easy to get at the table with every disease is rare, and you would acquire a trustworthy scheme because you're combating the other way of doing. Nevertheless, I'm firmly believe that the other scheme of acquiring all data I can grab will end. It will not go on between now and 5 years. There will be a serious decline, and maybe 10 years from now it's gone, because it's unsustainable. And interestingly enough, in the European Parliament as a whole, not necessarily the most advanced institutions of the world, they have accepted a motion. It's meaningless at this point because it's only a desire. Last year, that the acquisition of data from for the purpose of personal advertising should be forbidden. This is the first motion I know of from the European Parliament where they express insight into the mechanisms of the new technology and how they could intervene with that. But that motion is accepted, has been accepted, right? So that, but so we have to sort out, as always. You can't blame the public that they see these two types of AI use as all as one. But so it will take a lot of personal communication before it's separated, and we can easily, from the words of Blas, we can easily formulate another use of AI, namely when it's completely closed application. Why do we need this at all? Yeah, there is no real reason for it.
Yeah, and maybe that's a good moment to actually ask you, Blaž, how you see this with respect to the development of trustworthy AI systems in Industry 4.0. Is this privacy concern there a concern, or do you also see actually possibility to have this federated learning, or where basically we send algorithms to data, or you see other approaches there?
Yes, so the industry, it's very interesting. So manufacturing is very interesting from the perspective. So on one side there, when you're with whichever applications you're doing there, it's always the data that you have access is kind of core company data. So having so it's not medical, it's not the same as medical data, but still companies are careful about how they share, who sees the data and so on. And also once models that are built out of the data kind of capture. So just by observing, looking at the models you can see how the company functions. So just the models itself capture a lot of know-how and a lot of kind of internal kind of secrets.
So how you deal with this then? Do your customer actually trust your company that you would actually be properly taking care of this data, or you would apply certain privacy technologies, privacy enhancing technologies to deal with it?
Yeah, so we have to be very careful just where to draw firewalls to where particular data goes, what is extracted, what is sent there. And also we have, it's quite strict with respect to security protocols and everything. So you need to have all the ISO security standards and so on that, for companies to be willing to jump on board. And the second thing is also that kind of interesting from here is that most of the AI, I mean, most of lots of stuff is happening on the cloud, and for companies that are used to having everything on premise, have sending data to the cloud where it's kind of out of reach is also a big leap of faith in that sense. So there's a trust. It's independent of AI, but it's another level of trust they must have into that their data will be handled correctly by the external parties. There's another part of trustworthy is also there are tasks. So we have a very well-defined problem. So this was very nice analogy with putting a rope around. So kind of vision for quality control is very nice. You put the camera in front of the product, it checks, it says everything is there, parts are missing. So kind of well-defined, easy. If something is wrong, we can go back and check the picture and see where we were wrong. And then as you go a bit further down, it gets, so if you come to already predictive maintenance, which is still on a machine level, saying, now this machine replace this part because otherwise in 4 weeks you have a very high likelihood of a breakdown. So there's some level of trust between the vendor and the customer. So where do we put the thresholds? Did we went for precision or we went for recall? Do we, or we just want to, by increasing the threshold there, basically we can generate extra revenue with more parts. So it's a different type of trust, but it's there. So it's not.
So that's interesting. Yeah. And do you have experience with for example, federated learning? How would if you have in your company a data scientist, how data scientist would feel himself like to trust that actually, without seeing the data itself, that the algorithms that he would send to the customer, that actually these algorithms will create good models at the end. So without seeing,
even for federated learning, you need some form of feedback loops or some level of customers being able to report what is happening and getting some access to the system on the time when it's doing a mistake. So there must be protocols in place for that, because it's a big step to run something somewhere, especially with vision. It's just having local environment. Is it day? Is it night? Maybe the light is, the bulb start blinking. It's so many things that can go wrong that it's very, it's quite hard from the data science point of view. So in theory, it's quite nice, but there's, I don't know, somebody put a bottle in front of the sensor or something like that. It's lots of these little things that no model. I mean, it's hard in a model to account for, and if you're so having this good control of the data is important, and also having a good control or a feedback loop on for the end users to communicate back the errors, so it can be debugged.
Yeah, the one thing, because to connect also with the presentation of Arnold, is for instance explainability giving added value to trustworthy, for instance, also in federated learning, and how we can combine model explainability with model confidence to give to the user a score of a trust in the trustworthy AI system. Do you see some connection here, Arnold and Blas, explainability and confidence for improving trust?
So maybe I can go first. So this, I think explainability for sure it's very important, at least from my experience with talking to the end customers. It's once you have the initial numbers or predictions or whatever, it's nice. But or like this example that Arnold mentioned, driving on the autonomous driving on a highway. So it's if you would look on a on a one year period, number of mistakes a person would make or a computer would make, for sure computer would be, I think in these controlled settings would be more efficient. But once it does one mistake, everybody says, but I wouldn't, if I would be holding the wheel, I wouldn't be doing this. And it's at that moment, it's very easy to lose the trust. So this robustness or kind of having ability to communicate this confidence in the decision also helps in establishing the trust. So, and it shows that there are parts where the algorithm is more confident, part that is less confident. So we have these dynamics there as well. It's not only yes or no.
Thank you. And which is your view, Arnold? You mentioned explainability, but you see an opportunity to combine explainability and confidence to give trust to the user somehow?
Yeah. Well,
also in a quantitative point of view, like giving a quantitative,
One of the lessons I've learned from COVID is how incredibly difficult it is to bring across probabilities. Even for the masses of people in the Netherlands who have had a statistics course, still don't understand probabilities when it's in the real world, because they prefer much more clearness, so to say. So I would say that you can broadcast a posteriori probabilities, and they're easy to calculate. But I would be, for almost any application, it would be very good to verify whether the message had come across. That holds for in the medical profession. That holds in almost any profession. So for me, a posteriori probabilities, I'm not against it, it's useful, but it is still from the broadcasting point of view and not necessarily from the reception point of view. That would be my point there.
And how we didn't discuss. There was an interesting question from the audience from Anna Ortega Gill about the value of validation and in building trust, because I remember that many times, in healthcare also. For example, a radiologist would use MR machine and then would basically look at the images of the MR machine and would trust these images without understanding actually how this machine really works, because it's very complex machine with helium, with all the magnets, etc. So, and they still trust because it's validated. It has been shown in the past that it works very well. So, what is your view on AI and validation of AI algorithms?
Marcelo?
Okay, I can get started with this question. Well, I think it's a very valid one. It's a very good question. I will probably partly reiterate what I mentioned earlier. So I'm still skeptical that trust is the right word here, but I think we have a better word for defining the relationship between humans and machines, and that's reliability. And reliability is based on a statistical expectation that a certain system X will fulfill a task Y in a way that we instruct the system to do. And I think from this point of view, validating AI systems is a key prerequisite for reliability, right? So we can only have a system to which we can attribute reliability if it's adequately validated. And then there is a separate question, which is what kind of validation? Because sometimes we can have, proof of concept validation that works in an experimental setting, but then once we deploy the system in the real world, that system does not perform in the way that we expected. So we need to have a broad concept of validation. So one area that I'm very interested in is AI in healthcare, since I mostly work on medical applications. And in healthcare, you can really make the comparison between technology-based intervention and known interventions that are not based on technology. And for pharmaceuticals, for example, we have very strict requirements that we've been developing over time. We have clinical trials and we have double-blind studies and so on. We do not have exactly the same validation standards for AI. So maybe we should develop those validation standards, have a broad concept of validation that goes beyond the experimental setting and involves also real world validation. And I think once we have adequate validation, we will have reliable systems, which is a prerequisite not for trusting AI systems per se, but for making the public trust the AI industry, which I think is the important question that we should ask ourselves.
Milan, can I ask Marcelo a question, which intrigues me? So you wonder why AI, before it is even used on a massive scale, has already for quite some years public scrutiny, right? That if you look surely in the Euro Parliament, but also in the Dutch Parliament, whereas there are many things introduced in life, like nanotechnology, is virtually without any scrutiny at all, right? And the question is, why is that the case fundamentally?
I'm not sure I can respond on behalf of the European Parliament or any other institution. I think the reason why there is a lot of public policy interest in AI is twofold. There is a good and a bad reason. The bad reason is that I think that the AI industry is substantively hyped. And policymakers are just following the hype. Instead of deflating the bubble, they are reinflating the hype bubble. On the other hand, I think there is a good reason, which is what we call proactive or anticipatory governance. So you cannot regulate a technology only in a reactive way. So you wait until something bad happens or certain bad societal outcomes unfold, and then you react to that because it's typically too late. There is a famous adagio we use in technology assessment studies that says that it's always too early to assess a technology until it's suddenly too late. So I think it's very important to combine reactive approaches with proactive ones. So we need to anticipate the implications and the impact that AI systems will have on human societies. And sometimes, starting early enough is not a bad idea, as long as we do this in an evidence-based manner, rather than relying on pure hypotheticals or speculations. I think we need to do what we call in our field adaptive governance. So a governance that adapts to situations of uncertainty and is based on scientific evidence and is willing to change governance paradigms as we get more evidence or as our evidence changes over time.
And perhaps maybe also good to discuss trust in AI. We were discussing this topic, and now Arnold is also putting another topic at the table. Does that actually have to do with maybe potential of AI or maybe fears that people have? Because we often say, okay, if we keep AI under control, then AI can work for us as a human race, and if we lose control, then maybe that's the next step in evolution. So how you see that? Arnold, maybe you can answer this. Huh?
So in hindsight, you could wonder whether broadcasting that the world champion chess was beaten by a computer has been a bad thing in the history of AI. Because you can surely bet that it induced fear into many hearts. And the same, my father grew up in a time he had his driver's license at age 14 because there were only a limited number of cars. And if he would now hear that the next generation cars would have no chauffeur, his heart would be broken, so to say. Yeah? And so this invasion into typically things you have acquired to learn in your lifetime is one of the most fear-propelling things. And then it starts, we're old enough, Milan, that we've come in hospitals all our professional life. And the answer I had to answer most is, in all those 40 years, is when are you going to make me jobless? Which is totally ludicrous. And never was my intention, nor of Philips, or not of the government. Yeah, but so that's why the more I view of this, the more we should downplay what AI really can, not realistically, but so the world chess player algorithm can only do world chess. It cannot do the dishes. It cannot even
anything else.
presumably pass an exam. It can do nothing of all of this, right?
Yeah. No, thank you. Anything from you, Marcello, or Blaž?
Yeah, no, I agree with Arnold, and I also think that it is very important to consider this question within the right time frame, because in order for AI to become uncontrollable, so for humans to lose control over AI, then AI needs to outsmart humans. And I'm not among those who think this is logically impossible. I think there's nothing magic in the human brain that cannot be replicated in silico. But this is really a long-term scenario. So I would be worrying about this to the same extent that I would be worrying about overpopulation on Mars. Maybe at some point eventually this will become a concrete problem, but it's not something that doesn't make me sleep at night today. But at the same time, I think there is a ancillary question that we should ask ourselves. It's not about what happens if AI becomes evil, but what happens if other humans use AI in an evil way? And I think this is a very concrete question for policy and governance. You don't need to have a particularly intelligent technology in order to have a negative impact on societies. Look at social media, for example. There are pretty dumb platforms, but within the space of time of 15 years, they managed to reshape completely our notion of privacy and to influence political deliberation across the globe. So even technologies that are not particularly sophisticated can have a major impact if they're used in a certain manner. And I think the task of policy governance, but also of us as researchers, because we have a societal responsibility, is to try to anticipate these scenarios and align AI development with desirable goals.
Thanks. Francesca, are there other questions perhaps that maybe I think we are 7 minutes to go. Perhaps maybe there is one more question that we can try to address.
Yeah, one interesting question would be to address the new AI Act and its impact on AI technology. Maybe both Arnold or Blaž, or Marcello, if you are aware of that. Maybe one question which would be, which is the balance between innovation and regulations with respect to trustworthy AI in the new AI Act?
Well, let Marcello go first.
Oh, please do. I've been talking enough.
No. Well, okay. It's interesting to have read the new AI Act, and 304 people have filed an official reaction to it. So they have quite something to study. What I think is fundamentally wrong is the fact that AI is defined in the law, because it should not focus on AI. It should focus on anything and then be reasonable there. And why is that the case? Because if I were a lawyer at, say, Facebook, I know exactly what to do. As soon as this law is passed into law, then I would start a debate at the courts of what is AI. And this could easily drag on for a year, 13 years or so. So it has no effective power the way it is set up, because there is a boundary in the law. And on the other hand, I firmly believe that it's reasonable to regulate at least something. And these there are 6 very critical things mentioned. I'm expecting that when it passes to Parliament, 6 will be expanded to 8, or there will be another category and so on. So you can, so this is a sort of, and before the people will sleep bad because of what I say, you're opening doors you don't understand, and this is all very intermediary into what is really needed. And the really needed thing is to put the only thing which is accountable, the people who make this, into a mood that they produce responsible results, and with the proper intentions and proper care. That's basically everything that is needed at this point. And if the law doesn't make a very clear and built-in division of the types of AI systems we've seen at this table, when it's completely closed, why is a law needed? When it is for an idealistic purpose, like rare disease, all diseases are rare, there has to be another intent than when it is for deriving new businesses from privacy robbed and politically motivated social media use. So this is an intermediate law which will not last very long when it even gets to the point of being taken. And there are all sorts of opportunity to make it worse. Yeah. So.
Thank you. Maybe Marcello?
I agree. I generally agree. I should probably say up front, that we also have to try to be charitable, because this is a first of its kind legal framework on AI. So every new thing has its pros and cons. And when you have to invent something from scratch, it's very easy to make mistakes. And I do think that the current AI Act is establishing a regime that is both over-regulating and under-regulating at the same time. I think it's largely over-regulating beneficial AI applications in fields such as healthcare and transportation and many others, by creating a framework that is too heavy and too rigid, not sufficiently agile to address these challenges. And sometimes there are cases where it's under-regulating when it comes, for example, to face recognition for national security purposes, so by law enforcement agencies. So I totally agree that there is a lot of room for improvement, but I want to take a charitable take and think that it's an attempt, and more work will be done.
Fair enough. Yeah. And as I said before, one of my greatest dangers is data accumulation. Unreasonable accumulation is not treated yet. But okay.
And I think that this data, the data actually issue is maybe even something not related to AI. Obviously, we say yes, data we need for AI, but very often actually companies or others are collecting the data not for the reason of AI. As we are approaching actually the top of the hour, 1 minute to go, so I would like to take the opportunity to thank you, Arnold, Blaž, Marcello, for joining this panel. I would also like to thank the audience for listening. Obviously, there is a lot of opportunities for each of us to work on. We heard opportunities with respect to policy. We heard opportunities with respect to research, as well as industry to apply and build trust with the customers. So great way forward. So thank you again for joining this panel session, and enjoy the rest of the day.
Thank you, everyone.
Thank you.
Thank you.
Thank you. Bye.
Jessica, for chairing the session.
Thank you.
Thank you.